Yeah. Well, thank you very much. So today we're going to talk about magic, and you're probably bored of speakers saying this, but this is probably the most beautiful place I've ever gave a talk in, and I think this is a beautiful place to talk about magic. Now, I know that some of you don't like magic, especially in programming languages, but we can actually go back to the days that people were still using something called Twitter. I don't know what's left of it today, but Guido once wrote a message on there, of actually Guido in Dutch. From day one, there was deep magic hiding in some places, designed to quietly help users. Now, what Guido was talking about here is that in Python, there are a lot of magical constructs, so high-level abstractions that help us focus on our business logic. And we don't really need to dive beneath those abstractions to write what we want to do. We can just clearly express our thoughts and don't worry about all the implementation details that we need to get right. Now, there are a lot of magical abstractions in Python that we really don't normally worry about, like memory allocation and stuff like that. But there are also some kinds of magic in Python that we can actually use ourselves. So this kind of magic, this magic is found within Python's data model. And I want to introduce you to a particular piece of magic today, and it has to do with methods in Python. That's why this talk is called the magic of self. We all know the self parameter that we have in the signature of a method. And today we're going to talk about that particular piece of magic. And I hope to inspire you to dive into Python's data model, to see what it does, what you can do with it. But I also already want to tell you that you need to be a bit careful. Do write code that is easy to understand. So what is exactly the magic of self? What am I talking about? So here I'm going to introduce a very simple class for you. This is a guitar class because I love playing my bass guitars. And it's very simple because the implementation doesn't really matter. So here I'm defining a class. It's called guitar. I have a method that will initialize it when we're creating the instance. And I assign a single attribute to that instance, which is the name of the guitar. So something that I can do now is I can create an instance of the guitar class. I can give it a name, and then I have a neat instance. So then I can access that attribute, and not surprising at all, I will get the name back out. But now let's define one additional method here. And this method here is a play note method, which is much easier to write this way than to actually play on a bass guitar. You can pass a note to the method, and then we will simply print the name of the guitar, place the note, and then the note we've passed in. Now, this isn't a really difficult method. We can simply use our instance, Warwick. We call the play note method. We pass in a note that we want to play, a C# in this case, which is much better as a musical note than as a programming language. And then it will simply print out, my Warwick streamer plays the note C#. I'm kidding, obviously. I kind of like C#, but I'm afraid to admit that at a Python conference. Anyway, so if we zoom into this method, something interesting is going on, and most of us are so conditioned to working with methods that we don't really notice it anymore. So what's going on here is that if we look at our method signature, we actually have two parameters there. We have a parameter self, and we have a parameter note. Now, most IDEs and editors will use syntax highlighting to give self a different color, like I did here, so you barely notice it anymore, but it is actually just another parameter of this function. But when we call this function, I only give it a single argument, the C#. And if we look at that argument, it will clearly end up with the note parameter here. So what is self doing there? What is self? Where is it coming from? Why do we have something called self there in the first place? Well, that's kind of easy. It's a method on an object. We want to have access to that object. So where is this argument coming from? What is this argument? Now, what will actually happen here is that the instance that I've created, the Warwick, will be passed in as the first positional argument to this method. But if you look at this, it's not entirely clear why this happens. What's the mechanism behind this? And that's what I'm going to talk about today, and it will involve something called descriptors. Now, for good measure, this is the class. You're going to see a lot of it. It's a very simple class, but I'm going to use this one to explain the descriptors. First, before I dive into the magic, just a little bit about myself. My name is Sebastiaan. I live in the Netherlands. I work for a company called Ordina, although they won't be called Ordina for long. I'm also one of the founders of Python Discord, which is an online community for Python developers. And I'm also one of the organizers of EuroPython. And actually, I'm running for the board of the EuroPython Society this year. If you have no clue what the EuroPython Society is, you should talk to Mia, who can explain it beautifully, like she did yesterday in the lightning talks. But that's who I am. That's enough about me. So let's talk about self in Python. Cool. So how does self work in Python? Well, I've actually looked up a few tutorials online that try to explain it to me. And I've not looked at the good tutorials, I've looked at the bad tutorials, and there are a lot of tutorials out there that explain this in a very bad way. So one that I read said, well, because you use the term self in the function signature, that's why Python knows that it has to insert the instance here. Well, this is kind of true in some other languages. You might know self from Rust, but in Python this isn't the case. So if you don't actually like Python, you're a JavaScript developer, one thing that you could simply do is you can change the self in the signature to this, and this will just work. So I can just still call the method, and it will still work. I will hate you for doing this, but if you want, you can do this. I don't recommend you to. Self is such a strong convention in the Python language that it's all over the standard documentation as well. So please keep your code readable, but you can do this. And another way in which we can demonstrate this, what I can do is I can simply remove self from the function signature here. I can then call the method, and then things will break down. And this is one of the most confusing error messages beginners can be presented with, because it says that the function only takes one positional argument, but two were given, and then they tell me when they're talking to me, well, I'm only giving it one argument, where's the second one coming from? Well, that's what we're talking about here today. But this demonstrates that still the instance is inserted even if self isn't there in the signature. Another way that it's sometimes explained is that when you define a function like this within the class, within the body of a class, that's what makes it a method. So it's about defining it here, the moment that you define that class. But this also isn't true. We can simply rearrange the code a little bit. I can first define a function, just a plain old function that takes two arguments, one guitar and one note, prints the same message. I can then create the same class that I did earlier. I can then assign a class attribute playNote to that function, like I do here, and then if I use this method, it will still work. So apparently Python has still inserted the instance as the first positional argument into the function. So it's also not about a function being defined within the body of a class. So what's going on here? So in order for us to understand that, we need to look a little bit into how classes and attributes work in Python. So what I'm going to do is I'm going to show you our class. We're going to discuss what happens when Python actually parses this class body and will create our class for us. And the first question that we can ask ourselves is, what actually is a class in Python? After we've defined this and Python has interpreted this, what does it create for us? What is that thing in Python? Well, in Python, everything is an object. So when Python's done with creating this class for us, we will actually have a class object somewhere in memory, and we've bound the name guitar to that class so that we can use it. But while it's creating this class, when it's preparing the namespace of the class, Python will get to this definition. So what will it do at this point? At this point, the class doesn't exist yet because the body hasn't been defined fully, so it's still preparing the namespace. So what will it do when it gets to this statement? What kind of statement is this anyway? Is it a method definition statement? Is it a function definition statement? Well, if you look into the statements that Python has, this is just a regular function definition. So what this definition will do, it will create a function for you. And since everything is an object in Python, this will create a function object for you. Now, a function object just floating around somewhere in memory with no name attached to it is not something that's very useful to us. So what this statement also does, it will bind a name to that function in the current namespace. And this is very important here. Because we are defining the body of a class, the namespace of a class, what we will actually do is we will define a class attribute, so an attribute of the class object guitar, and we will then bind it to that function object. But it's important to realize here that the thing that we're binding that name to is still a regular function object. It's not a method at this point, or you could call it a method, it's good for communication, but it's still a regular function object. And the special thing that we've done here is that we've assigned a class attribute to that function. And that really is the first clue in our exploration of the magic of self. These are two important facts. We have a function and we've assigned a class attribute to it. So why is that important? Well, now we can talk about what happens when we access attributes in Python. Not regular names, but attributes on objects, so with that dot in between. And there we will find our second clue. So here I have my class again, and what I can now do is I can use my guitar.playNote, because this is a class attribute. We've just seen that. I can just see what happens when I access this attribute. And indeed, what we'll see is just a function. It's floating around somewhere in memory with a weird memory address there. But anyway, we have a class attribute and it's assigned to that function that we've created, that function object. But now there's something special in Python, something that we're all used to, that we use all the time, but it's actually a bit weird. We have a class attribute here, but when I create an instance of this class, when I create my Warwick Streamer instance again, and I then start accessing that same attribute, this is actually a bit weird because my instance only has a name attribute. I've assigned a name to it, Warwick Streamer, so why does it have a plain node attribute in the first place? You never really think about this, but this is because of the way attributes work in Python. So roughly speaking, oversimplified, we'll see later that this is not quite correct. What Python will do, it will first look at that specific instance of guitar. It will say, does this have a plain node attribute? In this case, it doesn't, so then it moves on to the class of the attribute, and it will actually go down the entire method resolution order to look if the class of the object has that attribute. And in this case, it does. So when we access this attribute plain node on the instance, we're not actually accessing an instance attribute, we're accessing the attribute of the class. So that's when we get the function. Wait, we don't get the function again. It works, but we don't actually get the function back. Now suddenly we get something back called a bound method. So why is that? I'm accessing the same attribute, but now I'm using the instance, and now I'm getting back a different type of object that somehow binds the guitar.playNote function to the instance guitar Warwick Streamer. And this is because attribute access in Python isn't as simple as you might think. You can actually manipulate what happens when you access an attribute. And this is where something called the descriptor protocol or descriptors come in. Descriptors are objects that you can implement that can influence what happens when you access an attribute. And that's part of the magic that's going on here. We access an attribute, and the method in which we access it determines what we get back. So some manipulation is going on. So what is that descriptor protocol? What is the magic of descriptors? Well, it's actually quite simple. It's not that complicated, but if you don't know that it exists, it really looks like magic. The descriptor protocol or the descriptor methods, they're well defined in Python's data model. They're just a bunch of 3 special methods, sometimes called magic methods or dunder methods, that you can implement for your own class that will then influence this attribute access. So there are 3 special methods, and they are probably for the things that you expect them to be. There's one called get, and this will influence what happens when you get an attribute. And this will be called both when you access the attribute on the class directly as a class attribute and using the instance. And then there's the set method. This one will be called when you're trying to assign something to an attribute. This will only be called if you use it on an instance, so not on the class itself. And then there's the delete method, which is whenever you use del. I don't think I've ever implemented anything with a custom delete myself, but maybe you have. So these are the 3 methods, and for today we only have to look at the first, the get method. And that's to make this a little less abstract, that's why I want to show you how we can implement a simple descriptor that uses that get method. So, what can we do? Here we have our trusty class again, and what I want to add to this class is a very special attribute called, I'm first collapsing the rest of the code, we don't need it. It's called isMyFavorite, and this isMyFavorite attribute, it will do a very simple thing. So if I have a specific guitar instance, like my Warwick Streamer, which is my favorite guitar, it's a bass guitar, it's excellent, I play on it a lot. What I then want it to do, if I access the method, the attribute warwick.isMyFavorite, it should return true. But when I have a different guitar instance, like my Fender Jazz Bass, which is also an excellent bass guitar, but it's just not my favorite, what I then want this attribute to do is return false, because it's not my Warwick Streamer, it's not my favorite bass. So how can we do that? Now, obviously, I could write a property, but let's do it by hand. So first of all, I have to realize that my favorite descriptor is another class, a class that needs to implement those methods. So let's first start out by writing a new class, favorite descriptor. And since I only want to manipulate what happens when I get the attribute, I'm going to implement the get method. And if you look in the Python documentation in the data model chapter, you'll find that this is the signature that they use. They have a self in there, which is for the descriptor itself, because this is a method of favorite descriptor. Then they have instance here, which is the instance that you access the attribute on. So in this case, it would be the Fender. And then we have something called owner, which is a bit confusing. The documentation says that this is the owner attribute, the owner class of the descriptor attribute. But even if it's further up in the MRO, it will still just be the actual class of the instance. So in this case, just guitar and not one of his parent classes. So now the first thing that we need to do when implementing this is realizing that isMyFavorite is a class attribute. So here I'm accessing it on an instance, Fender.isMyFavorite, but it would be perfectly valid for me to say guitar.isMyFavorite. And in that case, I don't have a specific instance. What Python will then do, it will pass none as the argument for instance. So I can simply write a check for that. If instance is none, I'm not accessing it on any specific guitar, so I don't have to check if it's my favorite. And I'm just going to return the descriptor itself. That gives you easy access to the descriptor, and this will make sense later on if we start looking at functions. If I do have a specific instance, like my Fender guitar, I make it pass this check, instance is not none, and here I'm going to do something really dirty. I'm just going to assume that whatever instance comes in has a name attribute, and I'm going to compare it to the string Warwick Streamer, because that's my favorite bass, and this is just an example. And when I have this, and this is my implementation of favorite descriptor, then things will suddenly just work. I can create a guitar instance, Warwick. I can access the attribute. This means that Warwick will be passed in as the instance. The instance is not none. I will make it past the if check. I will get to the return. I will compare the name of my Warwick to Warwick Streamer. They are equal. And now I will get true back. I can also do this for my Fender guitar. Access the attribute. Again, make it past the instance is none check. Get to the check line. Now the name is not equal to Warwick Streamer. And I will get false back. Now, and for completion, I can also use the class directly, access the class attribute directly. Since instance is now none, we will simply get the descriptor back. So, and this is basically a very simple example of a descriptor and how you'd influence the get method. And as you've probably guessed by now, all functions in Python are such descriptors. They all implement a get method. So let's look at the get method of a function and how it uses that to produce these special bound methods for us. So if you look at the get method of a function, it's written in C, but if you translate it to kind of pseudo-Python, you'll get something like this. And this is the get method. It looks nearly exactly the same as my example previously, because that was my intent. It first checks, am I accessing this function on an instance? If I'm not, if it's just a class attribute accessed on a class when the instance is none, I return self. In this case, self is just a function, so we get the raw function back. But if I'm actually accessing it on an instance, it will create a bound method for us. And the method needs to know what the function is, so it gets self as an argument, the function itself, and the specific instance, so it can bind the specific instance to the function, and this is basically how self works in Python. We can simply demonstrate that if I have my guitar.play node. I don't have an instance will be none, so what I get back is the function itself. Because it is more or less equivalent to just calling the method directly, the get method, with none and guitar. What I can also do is I can use an instance. I create my instance again. I will then access the play node attribute. Now my instance is not none. It's actually my Warwick bass guitar. So now we will get to line 8 in the get method, and there it will bind the function self to the instance to create something called a bound method. And this is because it's roughly equivalent to just calling the get method directly using the Warwick and the guitar in this instance. And this really is the magic of self. This is how Python binds that self argument, that instance, to the self argument as the first positional argument. It creates a bound method, which is a bit similar like a partial function, where you've already established the first positional argument, and this is how it works. There are also other built-in descriptors in Python. I will just quickly go through the most popular of them. One is the class method decorator. So sometimes when you have a method, you don't want Python to insert the instance, but the actual class object itself. So what can we do? We can wrap our function in another object, a class method object, and we typically do that using a decorator. And what this will do, it will add a wrapper around the function that just has an alternative get implementation, one that instead of inserting the instance, it will insert the class for us. We also have a static method, which is just another wrapper around a function with another get implementation, and this will not bind anything at all. Whether you access it on the class or the instance, it will just return the raw function for you. And then finally, and this is probably one that most of you have already used, the property. If you use a property, you can create a property object. You can give the property object a function that's used to delegate the get to. In this case, it's just a simple method. And now you can access the .price attribute without calling the method, because the property object will make sure to already call that method for you. And property is actually quite nice, because it also allows you to very easily create setter methods. So what it does, it will now use this method as the callback for whenever you try to assign something to the attribute price. It will actually call this method instead with the value that you're trying to assign, and now you can implement custom setter logic. You can also do this for a deleter in the same way with the property descriptor. Well, to summarize, what we've seen today is that descriptors allow you to customize how attributes work, and that Python's functions implement that descriptor protocol. They are descriptors, and they use that to create bound methods. There are also a few things that we haven't covered today. First of all, I've not gone into the set and delete descriptor methods. That's on purpose because I'm running out of time. I also not described something else, and that is that attribute lookup in Python is actually a bit more complicated still. There's the difference between data and non-data descriptors, and it has to do with the lookup order and precedence when you have a set and delete method. And also, I've not gone into the set name method. It's not strictly part of the descriptor protocol, but it's often used within descriptors to be aware of the name that was actually assigned to the descriptor. If you do want to read about those, there are, I think, two good recommendations. There are a lot, but these are the two that I've read myself. I think Fluent Python by Luciana Romajo is one of the best books on just Python itself, so definitely read it. The second edition is even more massive than the first. And there's also a descriptor how-to in the official documentation. It was written by Raymond Hettinger, which is also a very good way of really diving into data versus non-data descriptors. I think Fluent Python calls them overriding and non-overriding descriptors, but it's been years since I read the book. Okay, and finally, just to close, you do need to be a bit careful with this kind of magic, because there are a lot of ways that you can go. where you can go wrong, where you can implement magical things that hide from your user what's actually going on, where you're creating all this magical kind of input and output when you're just accessing attributes. So you do need to be a little bit careful. But I do like magic, because it allows us to create high-level interfaces for our codes. And finally, if you think that this is not real magic, I do have a quote for you. Just want to shoehorn this in here because I like the quote, and I'll end with it. And this is a quote by Lee Seagal in his book Net of Magic, Wonders and Deceptions in India, which is a great read. And the quote goes something like this. He is a magician, by the way. And he says, "I'm writing a book on magic," I explain. And I'm asked, "Real magic?" By real magic, people mean miracles, thaumaturgical acts, and supernatural powers. No, I answer. Conjuring tricks, not real magic. Real magic, in other words, refers to the magic that is not real, while the magic that is real, that can actually be done, is not real magic. Well, with that, thank you very much, and I'll see you at lunch.